So now that we have this basic program here, I want to enhance it by now also considering inflation. Because of course our real future value will depend on the rate of inflation we'll have every year. For example, if the inflation rate would be higher than the expected return rate, we would end up with less money after all these years than we had at the beginning. At least after considering inflation, of course. So the real value of that money. So how can we consider inflation here? Well, we can add a second line here and create a new variable that we could name future real value, which should be the inflation adjusted value. And here I want to divide my future value by 1 plus the inflation rate to the power of years. We could also merge it all into one formula, but here I'll split it up so that we'll have two values, which we then could also compare. Now in this program here, I eventually want to allow the user to enter values for the investment amount, the years, and the expected return rate. But I don't want to allow that for the inflation. Therefore, we could of course add the inflation as another variable here, but we could now also add it as a so-called constant by using the const keyword instead of var. With const, you still create a data container, just as with var, but unlike with var, you'll not be able to ever change the value stored in that container. Now we're actually never changing any of these values here either, so we could have used const here as well, but that will change in the future. So therefore here I'll add a new data container with const to create such a constant, and name that constant inflation rate. And then, just as with a variable, we should store a value in there. And here I'll choose 2.5, let's say, 2.5% per year. And you can of course choose any value you want. If you choose a value that has no decimal place though, you might want to explicitly set this type to float64 so that this inflation rate can be used in calculations without issues. Here I'll choose a value with a decimal place though. So with that we got that inflation rate. Now we can use it here in this formula by again using mathpow here and then passing 1 plus inflation rate divided by 100 as a first value to this POW function. So the same conversion we did with the expected return rate, I'll do it here with the inflation rate. And then pass years as a second value. And with that we'll get our future real value. And that's all. That's one way of considering inflation. And with that we can then of course also output that by adding another print line statement here. And here I want to output the future real value. With that, if we save this code, we can of course again run this application with go run dot, and as a result I now get two values here where the second value is the value adjusted for inflation. And as I mentioned, if we now would assume an inflation rate of let's say 6.5, which is higher than my expected return rate in this case, and I save this, and I then run this program, our inflation adjusted value would indeed even be lower than the starting value we had at the beginning. And that's how we can incorporate inflation here and how we can work with constants.